Okay, so we're going to talk about angles inside of a circle. This is two of the four types that we're going to learn. Central angles we've already talked about. We've been taking notes on it, and we've worked some problems over the last few days about central angles. A central angle is an angle inside a circle that has a vertex on the center of the circle. So you can see here, the pink angle right here is a central angle. And actually it creates two angles. It creates this little one right here, and it creates this big one outside of it. So those are two different central angles. The intercepted arc is the section of the circle that the angle crosses. So the green section of the circle is the intercepted arc for the smaller angle, and the orange arc is the major arc that is created or intercepted by the second angle. The measure of the intercepted arc of a central angle is equal to the measure of the angle. So in other words, the measure of the angle equals the measure of the arc. Or if you want to use symbols, you can say the angle equals the arc. All right. So here I have a couple of examples, and this one, we're looking for the measure of the arc, or this piece of the circle right here. And so since the central angle is 48 degrees, then we know that the arc is also 48 degrees. You might come across one like this, where the central angle is 90 degrees and the arc that it intercepts is 5x plus 5. Well, remember, these two are equal to each other, so you should be able to set them equal to each other, and usually it will be asking you to solve for x. So if you have to solve for x here, you would subtract 5 from both sides and then divide both sides by 5 to get 17. If I substitute 17 back in, this does in fact equal 90, which is correct because it should equal the central angle. Okay. We also talked about diameters a little bit. So a diameter is the largest chord that you can create in a circle. It goes from one end of the circle to the other side of the circle, and it goes through the center of the circle. Remember, the degrees on a straight line is 180 degrees, which means the intercepted arc of a diameter is also 180 degrees. We call that a semicircle. And it is usually named with 3 letters. Actually, it's always named with 3 letters. All right, the next angle we need to talk about is inscribed angles. An inscribed angle is an angle whose vertex lies on the circle. So now the vertex isn't necessarily, well, it won't lay on the center of the circle. It's going to lie on the circle itself. It still has an intercepted arc, okay, that lies across from it. So you can see that the vertex is on the circle. The arc is still called the intercepted arc. And here's what you need to know and be able to use. The measure of the intercepted arc is twice the measure of the inscribed angle. The measure of the inscribed angle is half the measure of the intercepted arc. So whatever the arc is, the angle is half of it. Whatever the angle is, the arc is twice it. Okay? Okay, so for example, if you're looking for the formulas, you could say that the angle in an intercepted or inscribed angle equals the arc divided by 2, or the angle equals the arc divided by 2. You could also think of it as 2 times the angle equals the arc, or twice the angle equals the arc. So if I have an inscribed angle with a measurement of 850 degrees, then the arc across from it has to be 2 times 50 or 100 degrees. Okay, if you have 2 inscribed angles that intercept the exact same arc, then the angles have to be congruent. So for example, I have a red angle here that measures 40 that intercepts this green arc here, and I have a blue angle here that also intercepts the exact same green arc. So if I know that the measure of the red one is 40, all I have to do is multiply that by 2 to get the measure of the arc, which is 80. If I want to get the measure of the blue one, all I have to do is take the arc of 80 and divide it by 2, and that gives me the measure of this inscribed angle of 40. So if you know one of the angles, you can always find the arc in the other angle by just multiplying it by 2 and then dividing the arc by 2. Okay, if you know one, you know the other because they have to be congruent. All right. Now let's look at the relationship between central angles and inscribed angles. It is one that's such that the inscribed angle is half the measure of the central angle. So for example, look at this circle. I have a central angle here of 76 degrees. Remember, central angles have their vertex on the center of the circle. And I have an inscribed angle here of 38 degrees because its vertex is actually lying on the circle. And both of these intercept the exact same arc. Okay? The arc measures 76 degrees because the central angle is 76 degrees. But we can also say that the arc is 76 degrees because it has to be twice that angle. Picture taking this vertex and sliding it back all the way across to the circle. Now it's twice as far from that arc. So it stretches that angle, and now the angle is only half as much as it used to be. Okay? So that's basically the relationship between central and inscribed angles.